Fine.
Morning, sir.
Good morning. Good morning.
Good morning, sir.
Acha, have you got the marks? Laboratory?
Yes, sir. হ্যাঁ
Yes. Very good.
স্যার কোথায় দেখতে পাবো?
হ্যাঁ?
কোথায় দেখতে পাবো?
পোর্টালে গিয়ে।
দেখা যাচ্ছে?
কে কে দেখেনি এখনো?
আমি দেখিনি
কে?
স্যার।
কে?
হ্যাঁ, আমি জানি না যে আপনি দিয়েছেন।
মার্কস দিয়ে দিয়েছি কালকে আমি। ঠিক আছে?
কিন্তু ওখানে দেখা যাচ্ছে?
হ্যাঁ, ও জাভাটা দেখেছিলাম, ওইটাই বললাম। প্র্যাকটিক্যালের আলাদা একটা কলাম আছে।
হ্যাঁ হ্যাঁ, তো মার্কস আমি কালকে দিয়ে দিয়েছি, প্র্যাকটিক্যাল একটা, থিওরিটা এখনো দিইনি, থিওরিটা দেবো। ঠিক আছে, থিওরিটা আজকালের মধ্যে দিয়ে দেবো। ঠিক আছে, তো যেটা আমি বলার জন্য বলছি আর কি, যে যারা রেগুলার গুগল সিটে রেসপন্স করছে না তারা কিন্তু কম নম্বর পেয়েছে। গুগল সিটে রেগুলার রেসপন্স করতে হবে, যারা রেগুলার রেসপন্স করছে তাদেরকে ভালো নম্বরই দেওয়া হয়েছে। অ্যাপার্ট ফ্রম দ্যাট, যারা কুইজটা অ্যান্সার করেছে, right, those who have answered the quiz and those who are responding Google form regularly, they, I hope, good marks, right? So those who have not done that, they didn't get probably good marks. Good marks means, what I understand, more than 80%, more than 80%, right? I have given more than 80% to all of them, those who are submitting regularly. Around 10-15 students I have observed that they are not submitting Google form regularly. If you are not submitting Google form regularly, then it will be a problem. Definitely you will get less marks. Regarding that, will be applicable to both theory and practical. In practical, there is around 20 marks for external viva and 10 marks for internal viva. Internal viva was not taken. Definitely Google form will be a criteria for the 10 marks. And external also, I don't know whether exam will be there or not there. Definitely 20 marks viva, that will be also depends on Google responding of Google form regularly. Now what do I understand by regularly? Suppose I have given quiz today, you have to answer at least by within 1 day or 2 day maximum, not more than that, right? So I am not asking for the same day. Like suppose I have given quiz today, I am not expecting that you have to answer in that particular day. You can answer tomorrow, day after tomorrow. So 1 day or 2 day, that could be there, but it is not that after 1 week or like that. Within 1 week you have to finish the whole thing. So those who are answering those things in time, definitely I hope they have got good marks. Now coming back to the subject,
স্যার, আর ওই 14 কোশ্চেনটা ওটা আপনি বলেছিলেন যে
ওইটা এখন আপাতত আমি তোমাদের বলার পরে যাদেরকে আমি বলেছি সাবমিট করতে, যাদেরকে এখন যাদের হবে না, মানে তাদেরকে আমি বলছি কাদের সাবমিট করতে হবে না। অনুষ্কা ব্যানার্জি এখন সাবমিট করতে হবে না। I will give you and I will tell you when to submit, but of course you prepare.
Okay, sir.
I am telling the name, those who don't require to submit right now, I will tell, and after that they will submit. I am telling the name: Anushka Banerjee, Kea Pal, Sanjana, then Ananya Ghosh, Oritriya, Amit Kumar Nandi, Arnav Bhattacharjee, then Nupur Vishnu, These people, Aritria, I have said few names, Anudatta, they did not, and Anusha, they need not require submit right now, right?
Yes, sir.
So these
Yes,
names
sir.
I have told already that you need not submit right now. I will give you the Moodle ID. Only you have to upload these assignment, right? So name that I have said they need not submit. Another name is Darshana Das. She also need not submit.
Yes, sir.
So I will tell you the Google and Moodle ID, then only you have to submit. Right now, not required, but if you have submitted, not an issue, you have to submit again when I will tell. So these people
Okay, sir.
that name I have told, they need not submit right now. Others, they have to submit
Excuse me,
or
sir.
mail me. Hi, tell me.
Sir, this is Pinakshmi. Will I have to submit?
Pinakshi, you can submit later. You also submit later. I will tell you the Moodle ID, then only you submit. The names I have told already, they need not submit right now. Others may submit. There are 2-3 names I don't remember right now. I have made this decision on the basis of Google form observation. Google form observation, what I have understood that definitely you are doing the thing and you may be provided the Moodle ID. So you did not submit right now. Others I have to mail. You have to mail by tomorrow. Other than these names, what I have said, rest you have to mail the assignment by tomorrow. Okay.
Yes, sir. Yes, sir.
If I tell, the others will submit. Okay. So I hope this is very much clear to you. And
Yes,
all
sir.
of you see the marks. Okay. Now we'll come to the topic what you call the FFT that we have started. Now regarding FFT, what I have discussed yesterday. Another important thing, yesterday I didn't send you the note and I also
Yes,
didn't
sir.
send the assignment because
Yes.
yesterday only I have started. So on the basis of that, I didn't give. But today I will send the note for yesterday and today. And today I will give the assignment containing the question from yesterday and today. So I will give assignment today. Okay. So this is the
Yes, sir.
thing you have to do. I will send you. Okay. Now coming back to the FFT, what I have discussed yesterday, let me summarize first. What I have said that endpoint DFT, that n corresponds to number of frequency domain sample. Number of corresponds to number of sample in the frequency domain. N corresponds to. And I have said that x of n, which is essentially signal, the length of the signal, if I denote by L, then that L has to be less than or equal to n. Less than or equal to n. If it is greater than n, if the length of the signal, if it is greater than n, then there will be aliasing or frequency domain overlapping. Frequency domain overlapping, we generally say aliasing. Therefore, the length of the signal that has to be less than or equal to n of the endpoint DFT, and that n corresponds to number of frequency domain sample. I hope this is all right for everybody. We have discussed this. Now another important thing I said that for endpoint DFT, we require n into n minus 1 number of addition and n square number of multiplication. And this addition and multiplication, that corresponds to computational complexity. Computational complexity means number of addition required and number of multiplication required. And from the expression of addition and multiplication, it is observed that it solely depends on capital N, which is the number of samples in the frequency domain. Therefore, if I reduce n, then my complex addition will be reduced and complex multiplication will be reduced, and thereby computational complexity, which is together multiplication and addition, that will be reduced. Therefore, if I am considering the FFT, FFT is essentially fast Fourier transform. Fast Fourier transform, that means FFT essentially a computation of DFT only, but only thing DFT is slower and FFT will be faster. So FFT, fast Fourier transform, is a algorithm based approach, and that will reduce the computational complexity. Now, in order to reduce the computational complexity, I have to reduce n. Once I reduce n, correspondingly, your xn also has to be reduced in number. Otherwise, that will not match, because I said that length of the signal cannot be more than number of points n in the frequency domain. Cannot be more than that. If it is more than, then there will be a aliasing. Suppose now I am saying that if I am asked to find an endpoint DFT and I want to reduce the computational complexity, then I have to divide it into, say, n by 2 or n by 4. For example, if n equal to 8, then if I want to reduce the value of n, means I have, suppose, say n by 2 I am saying, then it will become 4. If I say it is n by 4 DFT, then it will becomes 2. Another important thing I have said, that having understood the fact that if I reduce the value of n, my computational complexity will be reduced, then the point is, what should be the value of n with the reduced number? I said it will be 2. If it is 2, then if it is a 2-point DFT, and 2-point DFT, you require number of multiplication 2 square equal to 4, and number of addition 2 into 2 minus 1, that is equal to 1. So that will be reduced. Now, if I say 2-point DFT, that means my signal length would be at most 2. Now, suppose if I have an 8-point signal and I want to compute 2-point DFT and combine the result. In such a case, I have to select these combinations suitably. Not that x0, x1, x1, x0, x2. Which one to be taken with x0, which one to be taken with x1, that we have to decide on the basis of algorithm. That will come on later on, slowly. At this moment, what I have discussed yesterday, I have concluded two things, that to reduce computational complexity, we have to reduce n, and we have concluded that if I want to compute DFT, that computation will be computed on 2 points. These two things we have discussed. Any doubt if you have up to this? No? Very good.
sir.
Very good. Now I said that the suppose n equal to 8, and if I have want to compute in 2 to the power 3 8 equal to, so 2-point DFT I will compute, and I will combine the result in 3 stages. Okay, that we will understand in due course. At the time being, that will not be clear, because until we go into that level, when all stages will be completed, then only we can understand this thing. But now, to understand this thing, we required one more concept, that is called, suppose xk equal to this, n equal to 0 to n minus 1. This is the equation of endpoint DFT. Because how do you understand this endpoint DFT? Because this is n. If this is n, this is endpoint DFT, and this is 0 to n minus 1. Now, if I write x of k plus n, x of k plus n means n equal to 0 to n minus 1. I am replacing k by k plus n. Then it becomes x of n e power j 2 pi kn by n, because e to the power minus j 2 pi n into n by n, this will be equal to e power minus j 2 pi n, which is equal to minus 1 to the power 2n. This is equal to 1. Therefore, this equal to xk. So x of k plus n equal to xk, which means endpoint DFT is periodic with period n. Agreed?
Yes.
Endpoint DFT is periodic period n, which means, suppose if I have 8-point DFT, 8-point DFT, 8 corresponds to frequency domain sample. If it is an 8-point DFT, 8-point DFT is periodic with period 8. Suppose if I am talking n by 2, means 4. So 4-point DFT is periodic with period 4. Suppose I am talking about n by 4, that means 2. So 2-point DFT will be periodic with period 2. Agreed?
Yes, sir.
Very good. Very good. Now, suppose I have xn. Now I am decomposing xn into two parts. One is f1 of n, one is f2 of n, which is equal to x of 2n, x of 2n plus 1. This is nothing but your odd even problem. Odd even problem. This is also known as decimation in time. Decimation in time, right? Therefore, this technique, when I am dividing n, or when I am writing n by 2n, like x of 2n, x of 2n plus 1, this is called decimation in time. That's why this algorithm is known as decimation in time radix 2 FFT. Since I am computing in 2 points, then 2 to the power m to achieve the n point DFT. Therefore, this is radix 2, and I am computing the thing faster, reduced computational multiplicity. Then it is called first Fourier transform. And since I am writing x of 2n and x of 2n plus 1, that is called decimation in time. Therefore, total algorithm is known as decimation in time, DIT, radix 2 FFT. In short, DIT FFT. Agreed?
Decimation মানে কি স্যার?
Decimation means if I write x of 2n, that means I am taking the sample, suppose x0, then x of 2, x of 4, like that. That is called decimation. Okay, that means we are taking the sample one ahead of the existing order, 0, 2, then 4, then 6. That is called decimation in time. And suppose x of 2n plus 1, n equal to 0, x of 1, x of 3, x of 5, x of 7. So decimation is essentially the dividing the set in two parts on the basis of time, on the basis of time scale. That is called decimation. Suppose if I write x of 2f, then it will be decimation in frequency. Okay, so decimation is essentially a scaling operation, when k greater than 1. Okay, decimation in time is essentially a scaling operation. Okay, now suppose if I write x of 2n and x of 2n plus 1. Now I'm writing n equal to 0. f1 of n will be x of 0, f1 of 1 will be x of 2, f1 of 2 equal to x of 4, and f1 of 3 equal to x of 6. And if I write f2 equal to this, then this will be f2 of 0 will be x of 1, f2 of 1 will be x of 3, f2 of 2 will be x of 5, f2 of 3 will be x of 7. Now, if I look at here, your original signal x of n, that is having 8 point. See here, x of n having 8 point, x0 up to x7. Now, when this x of n is divided into two parts on the basis of time domain decimation or time scaling, then I have got two signals, one containing x0, x2, x4, and x6, another one containing x1, x3, x5, x7. Now, therefore, when I am writing f1 of n, this n will vary 0 to n by 2 minus 1. Agreed with that?
Yes, sir.
Because here n is taking value 0, 1, 2, 3. 0, 1, 2, 3, not 0 up to 7. 0, 1, 2, 3, because n by 2 minus 1 means 8 by 2 minus 1. So 8 by 2 and 4 minus 1 is 3, 0 to 3. So n will be varying 0 to 3, and f2 of n also n will be varying 0 to 3. In this also n will be varying 0 to 3. However, when I have written f1 and f2 together, that completes entire set of xn, which containing 8 samples or 8 signal values. Agreed? So x of n, how many points are there? 8.
স্যার আরেকবার বলুন, এটা বুঝলাম না।
হ্যাঁ হ্যাঁ
what I am saying, x of n, that consists of 8 signal points: x0, x1, x2, x3, x4, x5, x6, x7. Now, when I am dividing xn or decimating xn into two parts, one is f1 of n, another one is f2 of n. f1 of n equal to x of 2n and f2 of n equal to x of 2n plus 1. Now, in f1 n and f2n, this n will now vary 0 to n by 2 minus 1. 0 to n by 2 minus 1 means 0 to 3. N equal to 8 means 8 by 2 equal to 4. 4 minus 1 is 3.
Yes.
Great. Now, this n will be varying 0 to 3. This n also will be varying 0 to 3. And while this n is varying 0 to 3, I am covering entire set of xn. Xn consists of 8 sample. But when I am writing f1 and f2, n will be varying 0 to n by 2 minus 1.
Yes.
Another important thing at this stage, x of n, they are having 8 number of points. Now, I have to compute what? DFT of x of n. DFT of x of n I have to compute, right? I have to compute the DFT of x of n. Then I should have value x0, x capital X I am talking about. Basically, I have to calculate xk, which is x0 up to x7. That I have to compute. End result is that whatever algorithm we apply, whatever techniques we apply, my last answer, final answer has to be same. Is not it? Final answer of any technique should be same. Then only techniques will be valid. Is not it? Now, until I get the final answer correct, then this algorithm is not correct. Therefore, I have to get final answer correct. What I am saying, now when I am dividing x of n into two parts, suppose f1 of n and f2n, then f1 of n I am having 4 points and f2 of n I am having 4 points. And thereby combining f1 and f2, that covers entire set of x of n. Agreed?
Yes.
Very good. Now this is I am writing x1 of k. If I compute, that is n point DFT of xn. In this example, x1 of k is 8 point DFT of xn. Because I said that number of points cannot, number of point, n point. That means my signal length has to be less than or equal to n. So if I say 8 point DFT, that means my signal length could be at most 8. My x of n is having 8 points, not an issue. So what I am saying at this stage, that x1 of k is n point DFT of xn. For this example, n equal to 8. Okay. Now f1 of k, f1 of k, this is your f1 of n, right? This is your f1 of n. So it is having 4 points. This is having 4 points. Now at most I can compute 4 point DFT because signal is less than or equal to 4. Okay. Therefore, I am writing f1 of k is n by 2 point, means 4 points DFT of xn, f1 of n, and f2 of k is n by 2 point DFT of f2 of n. Do you agree with that? Okay. So therefore, x1 of k, I think this will be x of k, not x1. This is x of k. Okay. X of k is n point DFT of xn, and f1 of k is n by 2 point DFT of f1 of n. f2 of k is n by 2 point DFT of f2 of n. Do you agree with that?
Yes.
Yes.
sir.
All right. Now, coming back here. Okay. Now again, suppose I am writing this equation. N equal to 0 to n minus 1, x of n, w n, n k. Okay. This is what point DFT? N point DFT.
N point.
Because this is n and this is 0 to n
Yes,
minus
sir.
1. Very good. Now I am writing n even. Now I am writing n odd. Same equation. So n even means what I understand? X of 2n. And this xn I odd means I understand x of 2n plus 1.
Plus 1.
Acha. Now what will be the limit? 0 to n by 2 minus 1.
N minus 2. N by 2 minus 1.
N by 2 minus 1. Agreed? Now this will be when this is n, this is nk, this is n, now this is 2n. If this is 2n, I will write 2nk. If it is 2n plus 1, I will write 2n plus 1 into k. Agreed?
Yes, sir.
Fine. Now what I am doing, writing wn 2nk. I am writing e power minus j 2 pi into k, then 1 by n into n by 2, because you know wn nk equal to e power minus j 2 pi kn by n, right? If it
Yes,
is
sir.
2kn means 2 will be multiplied. If it is 2kn, so e to the power minus j 2 pi k by n into n multiplied by 2.
Yes.
Agreed?
Yes, sir.
But now this step to this step, what I can write? E power minus j 2 pi k into n by n by 2. Now, if this is true, then I can write wn and k means this is n, this is kn. I am writing wn this, and if this is n by 2 and kn, I am writing wn by 2 kn. Agreed? Okay.
N by 2 k. N by 2.
হ্যাঁ কেন হবে না? এটা যে নিচে n by 2 আছে, এখানে n by 2 আছে, এখানে যদি n থাকে সেখানে n, এখানে n k থাকলে এখানে k। নাও এখানে যদি n by 2 থাকে তাহলে এটা n by 2, এটা kn থাকলে এটা kn। এভরিবডি গট দিস?
Yes, sir.
আচ্ছা, যারা ক্লাস অ্যাটেন্ড করছো বাংলা বোঝে না কে আছে? হ্যাঁ, বাংলা বোঝে না কেউ আছে? কেউ নাই, সবাই বাংলা বোঝে?
হ্যাঁ স্যার
আচ্ছা ঠিক আছে, তাহলে কেউ নাই, ঠিক
হ্যাঁ।
আছে। পিনাক্ষী
আপনি
বাংলা
বাংলায় তো জিজ্ঞেস করলেন।
হ্যাঁ স্যার।
ওটা বুঝতে পারছি না।
Anybody who didn't understand Bengali? Anybody who didn't understand Bengali? ऐसा कोई है जिसको बंगाली समझ में नहीं आता हो? ऐसा कोई नहीं है, सबको समझ में आता हो।
স্যার
হ্যাঁ বলো।
ম্যাক্সিমামই তো মিউট করে রেখে দিয়েছে, এবার হয়তো শুনতেও পাচ্ছে না যারা হয়তো
তাই নাকি?
শুনতে পাবে না।
শুনতে কেন পাবে?
ম্যাক্সিমাম
শুনতে তো পাবে তো।
শুনতে পাবে কিন্তু মিউট করে রেখেছে তো, এবার ঘুমাচ্ছে কিনা স্যার আপনি কি করে বুঝবেন?
আর তো তাদের শুনবার দরকার নেই যারা ঘুমাচ্ছে।
তার মানে জয়েন করে ঘুমিয়ে গেছে?
হ্যাঁ স্যার, আমার
কারণ
হতেও পারে স্যার।
আমার মিশরাই আছে যে বাংলা বুঝতে পারে না, দেখছি এই লিস্টের মধ্যে তো তার কোনো রিপ্লাই নেই। তো রাজনীও আছে, তার কোনো রিপ্লাই নেই।
Okay, okay. So all right. So what I am taking now? So if wn k into 2n plus 1, so wn k into 2n plus 1, so e to the power minus j pi into k into 2n plus 1, that divided by n. So wn k into 2n plus 1, I can write it. Okay. Then if I can write this, e power minus j 2 pi k 2n by n and e to the power j 2 pi k n. So this is equal to, again I am dividing, it is n by 2, so wn by 2 kn wn k. Okay, therefore wn k times 2n plus 1, that will become wn by 2 kn into wn k. So now if I now write this equation 1, if I now write the equation 1, then this will be equal to x of k equal to n equal to 0 to n by 2 minus 1. I am writing x1 of n, x of n equal to f1 of n. Then instead of wn 2k n k, I am writing k times n into n by 2. Okay, so this will be equal to your wn by 2 kn. So I have written wn by 2 kn, and here it is wn k into wn by 2 kn. So f2 of n wn by 2 kn and wn k I have taken before the summation. Before the summation I have taken because that is independent of n. So when you are having the summation, if that term does not containing the variable, then you can take that sum out of the summation. Okay, if the summation is over n and the term does not contain n, is not containing the n, therefore I can take this sum out, then wn k out. Then what I am writing, this is n wn k into n equal to 0 to n minus 1 f2 of n wn by 2 k. Then this is equal to f1 of k, this is equal to f2 of k, and this is wn by 2kn, this is wn by 2kn. Therefore, your x of k, this is your what point dft, x of k, x of
K
k,
point.
huh?
K
x
point.
of n point, x
N
of k,
point.
acha, f1 k n by 2 point, and f2 of k n by 2 point. Now look at this equation. Look at this equation. If it is n point dft, this is n, this is 0 to n minus 1. Now, if it is n by 2, means this is n by 2, this is n by 2 minus 1. Okay? This is n equal to 0 to n by 2, this is n by 2 minus 1. So, this is your n by 2 point dft. This is also n by 2 point dft. F1 of k n by 2 point dft. F2 of k is also n by 2 point dft. So, what I'm saying that if f1 of k is n by 2 point dft and f2 of k is n by 2 point dft, then the total thing is your 8 point dft. Now my question is, what is the value of k? What is the value of k?
Okay, 0 to 7.
0 হ্যাঁ
0
0 to 7 হবে
0
to
7.
7. That is 0 to 7. That will be 0 to 7. Now you tell me one thing, that this k is varying 0 to 7, right? And this k is varying
0 to 3.
0 to
3.
0 to 3
3.
n by
ও আচ্ছা
0 to 3.
3
Now, and how it is possible?
Sir, I will know.
এর কথাগুলো কেটে যাচ্ছে
Suppose now is it okay? Now
Yes.
yes sir
listen. Suppose x of n is, in this example, x of n is 8 point. I mean 8 point dft I can compute. Therefore, I have to end result should be x0 up to x7. Okay. Now I am saying that x of k is the sum of 2 dft. If my x of k is 8 point, f1 of k, f2 of k is 4 point. Okay. Then f1 of k, this k can vary 0 to 3, 0, 1, 2, 3. f2 of k can vary 0 to 3. But x of k have to vary, k must have to vary 0 to 7. Then how could you calculate? Huh? Suppose x0, k equal to 0, that will be equal to f1 of 0 plus কত হয় বলো তো এক্সপ্রেশনটা? Suppose I am writing x of 0 টা কত হয় বলো তো এখানে? f1 of 0
f1 f0
and w8
Omega n 0.
omega
this is w
omega n 0 না সরি
WN0
w8 0
হ্যাঁ W80
হলো w8
F20
নেক্সট কত হবে? x of 1
f1
হলো এরকম করে 1, তাহলে এরকম করে
wn1
না ধরো এরকম করে 0 1 2 3 পর্যন্ত গেল, তাহলে x of 4 টা কি হবে?
f1
f1 of 4 w8 4 f2 of 4, তাহলে কি হবে? f1 of 4 টা কি হবে?
ওটা তো ব্যাপার না
ওটাই ব্যাপার না, f1 of 4 টা কি হবে বলো তো? কিন্তু আমি এখনো পর্যন্ত যতটা পড়িয়েছি এইটার থেকে তোমাদের বলতে পারার কথা, চিন্তা করে বলো তো f1 of 4 টা কি হবে? আচ্ছা anybody f1 of 4 টা কি হবে বলো তো?
0
f1 of 4 equal to f1 of
হ্যাঁ ওই ইয়েটা যদি হয় ধরা যায় ওই যে এক্সিস এরটা তাহলে ওই f1 4 টা ওইভাবে তো জিরোই হয়
কেন বলো তো? কেন জিরো বলো তো? না অ্যাক্সিস না বলো তো। আচ্ছা f1 of k, এটা যদি n equal to 8 এর एग्जांपलটা ধরি, f1 of k টা কত পয়েন্ট ডিএফটি?
n by 2 point
4 point.
4 point.
4 point.
Correct. N by 2 point also correct answer. 4 point is also correct answer. But 4 point is a specific answer. Now f1 of 4 is a 4 point DFT. And f2 of k also 4 point DFT.
4 point.
4 point DFT. Now x of 4 equal to f1 of 4 plus w8 4 f2 4.
Yes, sir.
f1 of 4 equal to f1 of 4, which is 4 point DFT. That will be periodic with period 4.
Yes, sir.
f1 of 4 equal to f1 of 0.
0.
0 plus 4, right?
Yes, sir.
f1 of 4 equal to f1 of 0. f2 of 4
Yes.
equal to f2 of 0.
F2 of 0.
Yeah.
Right? Similarly,
Yes, sir.
if I want to find suppose x of 5. X of 5 means f1 of 5 plus wn5 f2 of 5. f1 of 5 means f1 of
1.
0.
1.
1.
Yeah, 1. 0.
f1 of 5 equal to f2 of 1.
Yes,
1.
sir.
f2 of 5 equal to f2 1. Like that,
Mm.
if I go up to x of 7, then it will become f1 of 3 plus w83 f2 of 3.
Mm.
Now, what is the conclusion? What is the conclusion? Conclusion is, I have computed DFT for what? f1 of k, f1 of k, which is essentially 4 point DFT, which is essentially 4 point DFT, which is essentially 4 point DFT.
Mm.
Agreed?
Yes, sir.
f2 of k is 4 point DFT. Now, when I have combined these two 4 point DFT, what I have got? Result of 8 point DFT.
Yes, sir. Yes, sir.
So I have computed the DFT in lower point. Then I have combined the result, and I have got 8 point DFT. তাহলে 8 point DFT তে কত কম্পিউটেশন? x স্কয়ার 56টা মাল্টিপ্লিকেশন, সরি 56টা
Yes, sir.
অ্যাডিশন,
না, 56 addition
Multiplication 64.
64
Multiplication 64.
তাহলে আমি যদি 4 পয়েন্টে কম্পিউট করে সেটা কম্বাইন করি, তাহলে 4 পয়েন্টের জন্য কত হলো? 16টা মাল্টিপ্লিকেশন,
12 আর 16.
12 আর 16,
16.
12 আর 16 করে আমি দুটোকে কম্বাইন করে আমি 8 পয়েন্ট বার করলাম।
32.
তাহলে বোঝা গেল? তাহলে what I have done, I have reduced the first level because of 4 point. So I have reduced the multiplication and addition, but my result is 8 point DFT.
Yes.
Result is 8 point
Yes,
DFT.
sir.
So in this way, we can reduce the computational complexity of the problem. So next class we will be moving into next level. Suppose this is 4 point. Now I have to go for n by 4 point DFT. Okay, n by 4 point DFT. So if I go for n by 4 point DFT, then this will become even less computational complexity, which means even lesser number of addition and multiplication. Therefore, next class we will look to that aspect in 2 point DFT. Once I complete, I have a question.
স্যার বলছিলাম যে মানে আমরা তো স্যার এফএফটি টা করছি যাতে রিডিউস দি কম্পিউটেশনাল কমপ্লেক্সিটি, তা স্যার 8 পয়েন্ট টা যেরকম স্যার দুটো সেপারেট করলাম 4.4 পয়েন্টে, তা স্যার f1 কে এর জন্য ধরে রাখুন স্যার 16টা মানে 16টা মাল্টিপ্লিকেশন হলো, আর তাহলে f2 এর জন্য 16টা, তাহলে স্যার টোটাল তো তাহলে স্যার 32টা হচ্ছে মাল্টিপ্লিকেশন।
32টা মিনিমাম, এর সঙ্গে আরো কিছু অ্যাড করতে হবে, কারণ এগুলো কম্বাইন করতে তো মাল্টিপ্লিকেশন লাগবে, অ্যাডিশন লাগবে, ঠিক আছে? সেইগুলো অ্যাডিশন করেও আমি দেখাবো যে ওইটা নরমালের ক্ষেত্রে অনেক কম, ঠিক আছে? কারণ হচ্ছে কি, হোয়াট আই এম টকিং অ্যাবাউট, ধরো ইন্ডিভিজুয়াল গুলো কমলো, তারপর সেগুলো কম্বাইন করতেও তো অ্যাডিশন মাল্টিপ্লিকেশন লাগবে, সেগুলো তো এমনি কম্বাইন হবে না, সেটাও লাগবে। তো আমি দেখাবো যে 2 পয়েন্টে ক্যালকুলেশন করার পর, আফটার ক্যালকুলেশন অফ 2 পয়েন্ট, I will show you that total number of multiplication is much less compared to computation of that. ঠিক আছে? that
Yes, sir.
I will be taking in the next class. Today I am having less than 1 minute. So if you have any doubts, then you can ask. Otherwise, we would like to close the session. Any doubts?
এক্সামে যখন পড়বে তখন কি বলে দেবে n/2.50 বা n/4?
তোমাদের একটা 8 পয়েন্টে সিগন্যাল দিয়ে দেবে, দিয়ে বলবে এটার FFT বার করো।
আর 2 পয়েন্ট বা 4 পয়েন্ট যেটা খুশি করতে পারে?
না না, সেটা 2 পয়েন্টে এনেই করতে হবে, আমি সেটা বলবো। 2 পয়েন্টে এনেই করতে হবে, 2.4 পয়েন্ট যেটা কিছু করতে পারবে না। তোমাকে FFT কোশ্চেনটা দেবে, দিয়ে করতে বলবে। So you understand the theory. For exam point of view, I will tell you how to solve it quickly. That trick is there, I will tell you. Not an issue.